In this lesson, we're going to look at a problem in which two objects act as a system and in which Newton's third law comes into play. The question reads, a horizontal force of 600 newtons is applied to a system of two objects that are touching, causing them to slide across a horizontal surface. Mass 1 is equal to 12 kilograms, while mass 2 is equal to 18 kilograms. Mass 1 pushes on mass 2. The horizontal force is applied to mass 1. In this case, assume the surface is friction-free. Calculate the acceleration of the system. So let's begin by sketching a picture. We have M1 touching M2. M2 is slightly larger, and it's on a surface, and we have 600 newtons of force pushing the system to the right. So that's our little picture that describes what is written. So I want to point out a couple of things. Since it's a system, we know that the acceleration of object 1 has to be equal to object 2. So let's just call that A for the entire system and for each object. The other thing that we want to point out is that we have two objects here that are touching. So two objects touch. So the third law says that the force of 1 on 2 is going to be equal to the force of 2 on 1 in the opposite direction. That negative sign refers to the opposite direction. We call this the action force, 1 acting on 2, and this is the reaction force of 2 acting on 1 in the opposite direction. Again, the negative tells us that it's in the opposite direction. Okay, so now let's look at each object individually. So we'll begin with drawing a free body diagram. We know that gravity is pulling down on mass 1, and the surface is pushing up with a normal force we'll call N1. We apply a 600 Newton force to object 1, and object 2 pushes back, and we'll call that F2 acting on 1. So let's summarize the situation using Newton's second law for the y direction. So in the positive direction we have a normal force, and in the negative direction we have weight. So those two represent the sum of the forces, and when we add those up, that's equal to ma acting on mass 1, but we know that the acceleration in the y direction is equal to 0. So that means that the normal force on object 1 is simply equal to its weight this time. Now remember that the normal force is not always equal to an object's weight. Sometimes it's more complicated than that. This time it's simple. In the x direction we apply Newton's second law also. We have 600 newtons pulling to the right, and then we have the force of object 2 acting on 1, preventing or slowing down or retarding the motion of object 1. And that's equal to ma applying to object 1. So I'm going to say m1a. And again, we're going to call this a because object 1 moves with the same acceleration as object 2. So just want to keep that simple. Okay, so that's all we know for object 1. So let's look at object 2 now, M2. We know that gravity pulls that down with M2g, and the surface applies an upward force. We'll call that N2. And we know that object 2 is being pushed by object 1, so that would be the force of object 1 acting on 2. And that's it. The 600 Newton force, which is applied to object 1, is not applied directly to object 2, so we can't include it here. The only push on object 2 is the force of object 1 on 2, which we call F12. So let's summarize. In the y direction, we have the sum of the forces, N2 minus M2G, and that's going to be equal to M2 times 0. It's 0 because it's not moving up or down. And that means that the normal force on 2 is equal to the weight of object 2. M2G is the force of gravity. That's also called weight. In the x direction, sum of the forces, we only have one force acting on M2. That's the force of 1 on 2, the push of M1 acting on object 2. And that's equal to M2 times A. And it's the same acceleration as object 1 because they are touching one another, so they will move together with the same acceleration. So that makes that a system. So the next step, what we want to do is, we know something about M1 and we know something about M2. So I want to take those ideas and combine them together. So we're going to add what we know. Add what we know. And we're going to do that literally. We're literally going to add two equations. We're going to take the first equation in the x direction, 600 minus F21 is equal to M1A. That's the first equation. And the second equation is F12 is equal to M2A. And we are going to add them. So everything we know about 1 and everything we know about object 2, we're going to add together. So on the left side of the equation is going to be 600. Actually, let me finish it over here. 600 minus F21 plus F12. So that's the left side of the equation. 600 minus F21 plus F12. And that's equal to the right side of the equation, M1A plus M2A. Now, I'm going to make a point here. We made this statement here that says F12 is equal to negative F21. So F12 is equal to negative F21, which means that we can cancel these two. They're equal to one another. So we're left with 600 is equal to M1A plus M2A, and we can simplify that further. 600 is equal to M1 plus M2 times A, and we can plug in the numbers. 600 is equal to 12 plus 18A, and I'll continue here. 600 is equal to 30A. A is 600 over 30. So A is equal to 20 meters per second squared. So we've answered the question. And I just want to point out that in effect, if you have a system of masses which are touching one another, you're pushing the combined mass. That's what this is right here. So a force of 600 pushes on a combined mass of 30, so the acceleration is going to end up being 20 meters per second squared.